Hello, this is Jack Jackson, and today we're going to be looking at using Excel to compute parameters for some finite distributions. Parameters are things like, the ones we're going to look at are the mean, variance, standard deviation, and we'll even look at skewness as well. So let's start here with a completely blank Excel sheet, and we'll just build everything up from here. So here we're going to look at a column to start with for the data values, which I'll just label with the random variable x. And I'm just going to make up some sort of random x values here. 2, 5, 6, 8, and 11. And I'm going to make a row for a sum down here because I'm going to need that a little bit later on. And I kind of like to see things centered a lot, so I'm going to just pick up several rows here and center them. And we're going to have, just to make things look good, we're going to have some lines here and maybe some down here. Not sure exactly yet how many columns we're going to need, but we'll start with that. Now, in addition to make a probability table or a PDF table, we need a column with the values of the PDF or the probability values. Now, when I add these probabilities up, of course, the sum is going to have to be 1. And let's see. There we go. We have some values there. While we're at it, let's just do a couple other things, like maybe graph the PDF real fast. Spaced out correctly so that everything is even. So I need a space for 3 and 4, and for 7, and 9 and 10. So unfortunately in Excel I need to kind of do my table like this if I'm going to get it to graph correctly. Now I can use that to do my graph. The bars will come out, of course, the correct heights as they would have done the other way, but this way now they'll be spaced out horizontally correctly. We're going to change a few things here. So I'm going to right click on this. I can format the chart area. That allows me to maybe add some kind of color to the background, like that perhaps. I can do a few other things. I can click on this and say select data, and go on the horizontal category, edit that so that these values will appear down on the bottom. So now those are right. Okay, format the data series so that there's no gap and that the border has a nice line around it. And if I want, I can even click on this and say add data labels, and that'll put the probabilities at the ends of the bars. So there's a graph of the PDF for this function. Now the bars are spaced out appropriately. Okay, let's go back now and continue on to compute our parameters, which is the main focus of what we want to do here today. Now, to compute the mean, it's the expected value of x, and to find that, we take the x times the probability of the x. And so we want to do that for each of these. So we start a formula with equals, and we click on cell B3. We put a times, and which is asterisk, and then C3, enter. Now if I copy and paste this, notice that there are no dollar signs on this formula, so it's saying 2 to the left times 1 to the left, and that's what we want all the way up and down. So if we copy that, notice those were readjusted and worked out correctly. And I can copy this one, which is summing these 5 things above it, and that right there is in fact our mean. So let me make that bold and put a nice dark border around it. Could even shade it in a little bit if I wanted to, maybe a light color of some kind. How about a light purple? So there's the mean. Okay. Now, what if we want to find the variance, and from that the standard deviation? Well, this variance is the expected value of x minus mu squared. The mean, of course, is mu. So if I start by doing x minus mu, which is the deviation here, so that would equal x, which is B3, minus mu, which is D9. Now I want to copy and paste this, but this time I always want to refer to cell D9 specifically. So I've made it now where that row and that column will not change for the D9, but the B3 doesn't have that. So when I copy this cell and paste it, it will always be referring to where it did say B3, now it's B4, B5, B6, B7, so it's always referring to column B, but a different row, the one we're on. But the D9 is always referring to the mean. Next we want to take these values. Think back to our video, what we looked at when we interpreted this. When we interpreted standard deviation and variance just of a data set, if it's a population, this works exactly the same way. So we're taking each of these guys and squaring these deviations. So we found the mean. Each one of these in column E is the deviation from the mean. Column F is the squares of these deviations. Now what we want to do is to find the expected value of column F, which is take column F and multiply by the probability. So multiply the things in column F, multiply that by the probability which is in column C. And we want to repeat that all the way up and down that row. And then if we sum these, that is the variance. And if we want to find the standard deviation, that is just going to equal the square root, SQRT, or power 1/2 of the variance. And so now we have the standard deviation there. And so now we have computed the mean, variance, and standard deviation of this finite distribution. I'm not going to ask you to do this, but while we're at it, let's see if we can understand what's meant by the skewness as well. What we're going to do now is compute a z-score. Okay, now remember a z-score is the x value minus mu divided by the standard deviation. So x minus mu divided by sigma. Okay, so let's see if we can do that. That's going to equal parentheses x minus mu and divided by standard deviation. Now we want the x to vary as we copy this down, but we don't want mu to change or sigma to change. Sigma is the standard deviation, is 2.48 something, and the mu is the 6.75 right now. So now by doing it that way, if we copy and paste those, we get all the standard deviation, we get the z-scores actually of this. We want to cube z, then do the z-score, then do the skewness will be the expected value of that. So almost missed a step there. Take that and cube it. And we want to take the z cubed times the probability of x's. Let's do this again here. Okay, so this is going to equal the z cubed times that probability, and the z cube we want to change, but not the and the probability, actually we want all that to change, so that's going to be what we want. Make sure I got that right. Z cubed times probability, and just copy that and paste it down, and then we want to sum those, and that's the skewness. Very small skewness here, very close to symmetric. That seems reasonable from looking at the graph. And so we have computed several parameters here: the mean, variance, standard deviation, and skewness. And so now we have that for a finite distribution.